Our next speaker， 我们接下来的演讲嘉宾，他是来自 Scorum 项目的 CTO, and Alex is going to share enhancing Graphene infrastructure.
Greetings to everyone. My name is Alex Shkor. I'm a creator of two blockchain protocols, DEIP.world and Scorum.com. I'm here to talk about current infrastructure of blockchain. And first of all, I want to thank you for inviting me here. It's a big honor to speak at such a conference, and it's a big pleasure to be surrounded by like-minded people who are deeply involved in the blockchain movement. So in my speech, I'll share ideas about how we can solve current problems, because it's obvious that in blockchain there are a lot of challenges. And we already have some solutions for some of these problems. But what is most importantly, we have a solution to establish a continuous improvement for blockchain industry and Graphene framework especially. So what are current problems? User experience for an adoption rate for blockchain projects is really the issue. However, BitShares' team have done really great job in addressing this problem by introducing named accounts, free transactions, really fast blockchain which can be used like regular backend and with no delays for 10 minutes. But however, there are still a really big gap between current blockchain applications and their adoption rate and their user experience and classic web applications. And not having ability to integrate with third-party services, what we actually see in blockchain of BitShares as well, is significantly reduces capability of providing really reliable, agile, and robust applications. Scaling is always the issue, but in blockchain, for last years, it has become the main challenge. And there are still not really a silver bullet for this problem. And what is interesting is that blockchain by design is really embedded in scaling algorithm because it's distributed system, it's decentralized, and every node has replicating all state, and every node has consistency. But from another hand, to scale this one node to it becomes really complex problem because of requirement for strong consistency. So, and there are for sure multiple other challenges and problems which I may not listed here, but here are some main of them. It's like cross-chain communication, network synchronization efficiency, sidechain and off-chain integration. During the work on our projects, we are facing all these problems. And we needed much more efficient way to store content. We needed a way to integrate with decentralized storage and make it reliable and consistent. And what we have found for the problem of off-chain data storage and what we have developed, it's aggregation cluster. Aggregation cluster is a cluster of continuously syncing off-chain nodes which help to scale read data model independently from a blockchain. We came up with this solution during a research, and it's very important because we believe that any significant improvement to the blockchain system should go through the stage of research. Only after that go to development and testing. Because on blockchain, for example, on BitShares, there are a lot of people who have a big stake here, and these changes should be really proven in scientific way that we will not break the system. So therefore, we are not only introducing current solutions, because we also need to look ahead and to understand what we should do now to establish a platform for continuous improvement of blockchain projects and to supporting its both assessing, financing of such developments, and especially for the most important stage of these developments, the research stage. So let's look back at what we have now, and to what we have now in current blockchain infrastructure. So I would say that we are really lucky that we have a Graphene framework, and we are really lucky that we have chosen it for our blockchains. Graphene is really fast, especially if we compare it to other blockchain protocols. Graphene has outstanding performance because of its special consensus algorithm and because it's design of in-memory business processor, which actually was took from LMAX. So Graphene design is inspired by LMAX, which now states that it can process 6 million transactions per second. And LMAX built with same principles which Graphene has borrowed. So there are, as you can see, there is huge space for improvement and huge space for tuning and optimization of Graphene framework. Graphene is pretty reliable, and there are already many applications working on it. But the thing is that not all principles of LMAX architecture was taken into Graphene, and there are some really important principles left there that still can be adopted into Graphene, and that can not only increase performance, that can significantly improve capabilities of providing efficient and reliable solutions. Now we can bring the same principles to the Graphene and take Graphene projects which are based on this framework to the new level. But just say take these principles sounds simple. But to design an architecture based on these principles, it's really complex task. Graphene processes every operation in the single thread. And this is basically the same what LMAX does. But what is different is that Graphene stores all read model also in this single thread and updates it in all single thread. It consumes much more computation power than it would consume if we move this read data out of business processor. And this is basically how is LMAX designed. So and LMAX design was borrowed by Graphene by really specific reason, because LMAX at that time was the best and the fastest matching agents for centralized exchange. It was really the right choice to develop a decentralized exchange on the same architectural principles. And as I already said, Graphene processes also a read data in business processor, which is single thread in memory, really fast, but stores a lot of data there, and really efficient. But LMAX never store a read data in a business processor. And it never, in UI, or user interface of LMAX never reads from business processor. It's highly inefficient. Yeah, actually, it's highly inefficient, but still allows Graphene to process 10,000 transactions per block. But if LMAX will do this, it will just kill all that performance. So what I propose is to move also read data, read model of a Graphene framework into separate aggregation cluster. This data of this read model will be not in a strong consistency, which is really required for business processor, but not required for read data. So you may think that it will break the system, but it's not, because read data is always in eventual consistency. Because once we have displayed it to the user, it's already obsolete. So you cannot display the same thing which is in a consistent storage. Because while it goes to the user, to the network, it's already can be obsolete. You cannot ensure strong consistency with the data, with the read data. So it means that there is no sense to store it in a write model, read data. And this principle of data separation is not only for LMAX, actually. It's really common in distributed system. And it's really common in a CQRS paradigm, which stands for Command Query Segregation, Command Query Responsibility Segregation. This is a principle I've been working with for about 8 years already, and with which I've designed dozens of architectures. And I've applied this principle to design aggregation cluster. So basically what it does, aggregation cluster allows to move all data which is not needed for validation of domain rules to off-chain data, out from business processor, and keep it in self-balancing, self-scaling cluster of nodes, which will significantly reduce a data stored in the memory of blockchain database. And once it's done, Graphene Business Processor will not only, in Graphene Business Processor, will only left a data which is required, which is required for write operation. But all read operation will be moved to aggregation cluster. And not only less data will be in business processor, there will be much less operations applied. So because now when we apply write operation, for example, we need to check that the simplest write operation in Graphene Business Processor is transfer, and you need to check is it enough balance. And for write model, it's just enough to check that it's that there is enough balance and update this balance. That's it. But in the shares, we updates the whole history of accounts and a lot of other read data, which is not really needed to be processed in business processor. And why it was not done before? Actually, it's rather complex task to design the aggregation cluster in such a way that it will be still consistent with write model, because we cannot just produce the stream of events. We still produce events in output disruptor, but the aggregation cluster should be able to self-fix them himself, because in blockchain every time we can we should be able to unwind transaction. It's not something that is really common in traditional databases and traditional services. But aggregation cluster can do this, and can do this automatically. So once we have aggregation cluster, we can easily integrate any kind of tool, any kind of database into read model. And it will provide us ability to make a full text search indexes, graph-based databases, geospatial indexes, and even neural networks training sets that will be constantly in near real time updated through aggregation cluster. Now with aggregation cluster, we can build much more comprehensive systems, like fully functional social networks for traders, for example, or integration with artificial intelligence for governments into blockchain, or create fuzzy search for text data, or at least move account history data out from BitShares. This is something that is really beneficial for every blockchain which is built on Graphene framework. So it will be easily integrated, and any project who already was on this stage and who are also building their chain with the Graphene framework. As I already said, so this new Graphene architecture allows to implement really any kind of applications and make blockchain applications really, really close to the experience we have with traditional web apps. So with it, we can do real-time analytics tools and any machine learning integrations, data analysis, predictions, and so on. So let me add a few words about people who are working on building the new infrastructure for Graphene. We have two great teams. Each one is brilliant in their specific expertise. Scorum is sports media blockchain with decentralized advertisement system and betting exchange. Scorum is already live, and soon new functionality will be delivered. At Scorum, we have a great team of front-end and blockchain developers, great marketing team and PR, and for sure UX and user interface designers. Another Graphene-based project which I have founded and leading right now is DEIP, a decentralized research platform entirely governed by the scientific community and driven by internal economic model. DEIP now in the pre-sale stage and runs in the beta mode with already developed and tested blockchain protocol. At DEIP, we have experienced blockchain and distributed system architects, crypto economy protocols experts, artificial intelligence specialists, data scientists, mathematicians, and researchers. But having a great team actually is not enough for future development. So it might be enough to solve challenges what we have right now. But in future, with continuously growing blockchain industry, we will have more and more challenges. And we need to scale quality and volume of development work we can perform in this and challenges we can solve. So for this, we need to establish a process, a system, an environment which will support continuous enhancement and promote quality. It should be a decentralized system, definitely. So BitShares already showed that even simple worker proposal really works, and it has proved that blockchain can fund the real world in real world team of developers. But this decentralized system should provide open access to every research which is done there. It should provide a decentralized assessment of the work which was performed and provide a funding for this research. And the best way to provide funding is in decentralized system is to automatically distribute the reward depending on the quality of work performed. So it's the most scalable system you can ever imagine. Nobody needs to control it. So we have actually a lot of ideas of research which can really enhance Graphene infrastructure and blockchain industry in general. Today we propose these specific research projects and have many more in our backlog. Our goal is to significantly improve current system, enable smooth integration of them into our society, and create strong foundation for the future of blockchain protocols and applications. Here are a few researches which we already started or going to start in near time. So, for example, advanced ICO models on Graphene-based blockchains. The goal of this research is to answer questions. Which ICO model will be most beneficial in terms of fundraising? Which will be the most secure in terms of investors? How these models should be implemented in a decentralized system, especially in Graphene. ICO as a model for fundraising already have eaten a big portion of market in venture capital. And there is a huge potential in it. We are ready to discover them and with a scientific approach and create mathematical models of market analysis. These models implemented for Graphene framework could be easily integrated into any Graphene-based blockchain. Another potential we see in blockchain research is comprehensive trading orders. So what type of order will provide most liquidity on decentralized exchange? How these orders should be implemented? What type of new orders are possible to create? Completely new orders possible to create on the decentralized exchange. Maybe some floating commission rate which is controlled by a protocol and which rewards and incentivizes users to trade with a bigger volume. So there are a big variety of possible trading orders we can create. And the decentralized exchange, especially BitShares, could become a trendsetter for whole industry if we pursue a target of discovering, creating, and implementing new type of trading orders into BitShares. As you can see, there are many other research we are proposing, like horizontal scalability of blockchain, instant cross-chain communications, mathematical models for most efficient emission distribution in a blogging system, expertise token system for decentralized assessment and funding of any scientific project. And these actually researches, these are not fundamental research, these are applied research, which when done, can be directly implemented into Graphene-based projects. And DEIP actually allows to incentivize best experts in scientists to work on these research projects and being paid either by platform itself, either by investors through decentralized research platforms. And yes, each research on DEIP is tokenized, and these tokens not only represent the ownership of research, but also could for many years generate an income for research token holders. Therefore, these tokens could be also offered for venture capital investors and be traded on the secondary market. With DEIP, we not only attract a lot of human capital to work on blockchain research, we can do this for any scientific discipline. And this is a great opportunity to show the world how crypto economy could support science in much more efficient way than current system does. And imagine how early adopters of this system will benefit from taking the first place in the row and attracting best minds to work on challenges in their projects and in their industry. And I have no doubt that blockchain industry should be the first player here and the main beneficiary. Thank you. So, and want to add that since all research tokens, all research are tokenized, we will make an airdrop for every Graphene community member who contributes to whole Graphene industry. So, thank you.